So, when we start to make a piece to carve on the robot, we're going to set the model up in a very specific way. The first thing we have to do is we have to model the bed that goes on the robot, and then we have to model the block that we're going to use, and we have to put our model in that block. So we've modeled our bed at 72 inches by 48 inches by 1 inch. We place that at 0, 0, 0. Then we make a 6-inch tall block. That's 24 by 24, because the blocks that we use to carve are 24 by 24 by 36 tall. So we make this 6 inches, because then that lets us avoid our L brackets that we put in to hold the piece, and we don't have any issues then with accidental collisions with the bed. So then we place our model inside the block, and then we make another block that's 24 by 24 by 30 inches tall. And this will export as a separate file, and this will be our stock. Our stock is the part of the model that will be carved away in PowerMill. So I have these ready. I was just finished setting them up, so now we're going to open PowerMill. So I'm going to open PowerMill 2017. So we're going to reset the feed rate. Click OK. Once the program opens, then I'll adjust the settings. Okay. Our spindle speed we have at 6,000 RPM, and that's determined by our tools. Tools are made, when they're made, they have a certain balance that lists the optimal range. So our tools are in a tool holder, so we're already set on that. Our feed rate is going to be 18,000 millimeters per minute. Plunging feed rate 3,000 millimeters per minute. And our skim 12,750. Okay, so we're going to close that because that's set. So the first thing we need to do is get familiar with, this is our work plane window, our exploring window. We have our PowerMill Explorer, which has our different groups that we're going to use. It has our machine tool, our tool paths, our tools, our boundaries, patterns, work planes, models, stock model. These are the different things we're going to work with. And then our plugin window has the different actions we're going to take when we do our simulations and writing our program. That'll be over here in the vertical plugin window. So the first thing we need to do is I'm going to bring in our robot. So on this version of 2017, there are copies of all the different sections in the vertical plugin window. So we have to use the second version. So we're going to go to the bottom robot library, open WPU, expand WPU, and choose WPU no table. And you can see we've loaded in robot setup. It has our robot arm, with our spindle head. There's a turntable and the controller modeled into it, as well as the tool changer. So we will also need tools. So the next thing we're going to do is right click on tools, go to create tool from database. So in our database we have the 10 tools that are in our tool changer. So I'm going to choose, using the shift key, all of them, and click the button that says create tools. You can see by the bar down here that that is loading. Okay, that's finished. I'm going to close this window. If we look at tools, we can see that now we have all the 10 options to choose from. The next thing we need our model. So I'm going to go to model over here and I'm going to right click, import model. Our file is in Faraday Robot Carve 2. That was not the right scale. I think it's the other one with the same title. There we go. So to navigate in our Explorer here, we click and hold the mouse wheel to rotate around. We can zoom in and out by scrolling the mouse wheel. We can pan by holding shift and use the mouse wheel button. We also have a home button, which takes us to the top view. We have our trusty box here that we can hold and rotate around. We have key points like 45s, 90s. We can rotate using the rotation arrows that way. So that's how we can rotate and view our model in the work plane window. Also, like we had doubles in our vertical plugin window, we also have a double of our replane analysis, and we want to use the second one. So I'm just going to click on that now, even just before I forget. Okay, so we have our model, we have tools. We also need our stock. So I'm going to click on block up here. I'm going to choose triangles, because the file we're importing is STL, which is triangles, and global transform. I'm going to click the folder. I'm going to find our... I have to make sure I'm looking for an STL. Gives me my measurements. I'm going to click accept. And then over here, if I click this block, it'll give me a view of the stock, which looks correct. So we have our model, we have our stock, we have our tools. So now, to start carving this, we have to see that we have a block that we need to carve down a lot to get to our model. So we're going to start off, and this is true of any kind of carving that we're going to do, with a roughing pass and then finishing pass. And the roughing pass is going to be aimed at clearing as much material as possible. And we're going to want to use larger diameter tools. So I'm going to go over here to toolpaths, right click, create toolpath. We're going to start with a model area clearance. Click OK. So here's our window for the settings for this type of toolpath. I'm going to change its name. I'm going to call it RGH1 spelt out, because I'm not going to use any numbers in the naming of our toolpaths or of our simulations or of our program names, because that confuses the robot controller. So if I need to number things, I'm going to spell numbers out or use ABC, like that. So if we look at our model area clearance here, the first thing is a work plane. Work plane is the direction in which our tool is going to approach the piece. So we need to create a work plane. So I'm going to come to our Explorer, go to work plane, right click, and I'm going to create and orient a work plane using the block. So this gives me control points on our block. I'm going to want to come in to our piece on this side. So I chose that way. So now I want to edit this work plane, because right now it has Z facing up, which would mean that the tool would come straight down. Our Z on our XYZ, on our coordinates, we have one for the world, which X faces away from the robot, Y faces to the left, and Z faces up. So that's for the world. And then we have one for our tool, which we can see here. And Z faces into our spindle. So when we create a work plane that we're going to use, we want our Z to face away from our model, to face the same way that the one for our tool does. So I'm going to hit the plus sign and click on our first work plane, and I'm going to go to work plane editor. So yeah, see our Z is vertical. We want to come into this model not at 90 degrees, because then we still have the chance of hitting our bed, but somewhere in between these. We've found that a 60 degree angle is a good angle to work at. So we're going to twist this work plane on the X so that it is 60 degrees. I'm going to accept that. So now this is the angle which our tool is going to come towards our model. I'm going to click the green check. So now I'm going to choose work plane 1. Our block we've already defined, that's good. Our tool, now we have to choose our tool. To do roughing, I'm going to use our 1-inch diameter, 12-inch long tool, the biggest, longest tool we have. Our machine tool, we don't need to change that setting. I'm not using a limit as in a boundary for this toolpath. So now our settings for our model area clearance. We want it to be offset all, which it means it offsets the model and the stock. Cut direction, we're going to choose any for the profile, and area any. This will be determined by our material, and since we're using foam, we can do any and any. When you have material that has a grain, like certain woods, harder woods, or if you're doing metal or stone, you want to maintain a certain direction with your cuts. Our tolerance, I'm going to move to 0.5. Our thickness, we want to be 7. This is in millimeters. So 7 millimeters is just over a 1/4 inch. It's what we're going to leave. So that means that this tool isn't going to get any closer than a 1/4 inch to our model on this roughing pass. That leaves us room for error, and we can change to a smaller tool to do our finishing pass. Step over is going to be half the diameter of our tool. We have a 1-inch tool. 1 inch is 25.4 millimeters. So half of that is 12 millimeters. And that's how far the step over is, how far over each tool pass is from the last one. So if it's 12 millimeters, the tool is taking half its width of material every time. Step down, we're going to do 75 millimeters, which is 3 inches. And because of the material, the soft EPS foam, this is possible. And we have a very long tool. Constant step down always needs to be checked. Offset that we're going to double check. Profile any, area any. Step cutting. So in our area clearance, we chose a step down of 75. So each tool pass goes 3 inches down. Now step cutting is on each of those 75 millimeters down, then there would be a big 3-inch kind of cusp, kind of rectangle. So rather than have that, we're going to change this to 7 millimeters. And so then it steps down 75 on each cut. It does a full layer. And then when it gets close to the model, it comes up every 7 millimeters to keep from having big angles when we do our finishing. Wall finishing we don't need to play with that. Flat machining we don't need to do. High speed order is fine. We don't need to change approach. Automatic verification. Thickness is 7. We need to check automatic collision checking against the model in stock. And we're going to choose 2 and 2. So this, when we're generating a tool path, we'll check to see if our tool holder or shank comes within 2 millimeters of our stock or our model. And so the shank is the green area of the tool where there's no more blades, but there's just round flat metal on our tool, and the holder is the red, which is what holds the tool in the spindle. Cutter compensation we don't need to do anything with. Point distribution we don't need to do anything with. Tool axis should always be vertical for roughing passes and the finishing passes that we're going to deal with. Machine axis control, always free. Now rapid moves. Rapid moves are the way the robot makes moves that aren't cutting moves. So say it made a cutting move up in this corner, but then it needed to, the algorithm determined that then it was going to start back over at this corner. So we are calculating the rapid moves to be in the right orientation along our work plane and also a safe distance away from our model. So we can see that it is back from our block and in line with our work plane. And it's 10 millimeter clearance, which is 10 millimeters from our highest point in that Z direction. Leads and links. This is how the tool approaches each pass. We're going to do a vertical arc. Angle 90 degrees, radius 12. And I'm going to click this button to make the lead out the same. first and last leads, we don't need to separate one. Lead extensions, we don't need links. I'm going to make it straight, skim, incremental, start point, first point safe, end point, last point safe. Double check my feeds and speeds. I had that at 3000, so I'm going to adjust it, and I'm going to click calculate. So now it's calculating the toolpath. It's running an algorithm to take all of those settings into account based on the size of our stock and the shape of our model. Okay, so our toolpath is generated, and it's a clearance. It comes in, we can see what the different colors mean in terms of our toolpath. The green are our cutting moves, so I can turn them off or on. The pink are our links. And the links are what connects if you have to make a movement in between cutting areas. And our leads are the orange lines. So that's how we can visualize what this toolpath that is generated means. So it comes in and it makes concentric circles to cut that area. Then it cuts down and it makes concentric circles to cut that area. And it does the same. Now it starts to hit the model. So then we have the 7mm step up and the areas where it starts to make contact with the model. But right now we can see that we didn't limit it, so this tries to cut all the way through the block. We're going to run into issues with that. So now we're going to limit this toolpath. So I went right-clicked on the toolpath, said Edit, Limit, and I brought up this screen. So to use this screen, I also have to deactivate temporarily my work plane. I'm going to right click on my work plane and click on the check that's next to activate. So now we're going to limit this toolpath based on the world coordinates rather than the work plane coordinates. So I want to trim it on plane Y. And I want to trim it about in the middle. So I'm trimming it on the Y, which is the vertical in relation to this view. And this inner, outer, or both will determine the direction we're going to save. We can tell by the arrows. So inner is the side I want now, but just to show, outer would be that way. Or if I wanted both sides, I can save both. But I want inner. I'm going to delete the original. I'm going to click apply. Okay. So now we can see that our toolpath has been trimmed to that plane. That's what we want. So now I'm going to close that window. So now we have a toolpath generated that is ready for simulation. First, let's save our project. We're going to File, Save Project. I'm going to save it in our shared file folder. So now I've saved the project. So when we edited our toolpath, it gave us a _1. That we can just delete from the name of this toolpath because we don't want any numbers. So now we want to come to our vertical plugin window and we want to go to robot control because we're going to use that to simulate this toolpath. And the simulation is determining the angles to write the program. We are saying if this tool follows these lines in this pattern, what are all the angles of the different joints in this robot at each point? And that turns into our robot program. To do so, we have to use, under tool control, we have to use vector. We have to turn our turntable's tolerance from high to static. This will mean we can set it at a certain degree and then leave it while it runs that toolpath. So, if we look at this from the top, we're going to hit the home button to home our robot and a turntable. So the turntable is a 360 degrees, it's a circle. So I'm going to say 330 degrees. If I went positive, it goes counterclockwise. I'm going to click this yellow exclamation point that snaps my tool to the start of the tool.